Greetings, grade 8 social science learners. Today I'll spend some time doing the memo for the revision worksheet that you have been given on Friday. Please mark your work as we are moving along. Question 1.1 talks about a book of maps. In other words, it's where all the maps of local areas, of international areas, of provincial areas are put into one book. And that's referred to as an atlas, right? So there's your answer there. That's referred to as an atlas. The central line called the equator. Now, the central line that is called the equator is referred to as the latitude. Latitude are lines on a map that run from east to west. They're the sleeping lines. For example, here are your lines of latitudes. The one there is the Arctic Circle. So there you have the Arctic Circle, right? So there's a line there. That's your Arctic Circle. Then you have the next line. That's your Tropic of Cancer. All the way there is our Tropic of Cancer. Then dividing our two hemispheres is the equator. That's 0 degrees. It runs in the center, and that's called the equator. Moving further on, there you have your Tropic of Capricorn, right? Lines of latitude. And the last one at the bottom is the Antarctic Circle. There's it there, right? The Antarctic Circle. There you can see you have your North Pole. And at the bottom here, you'll note you have your South Pole. So the equator is a line in the center, which divides the Earth into two hemispheres, the Northern Hemisphere and the Southern Hemisphere. And there's your line, there's your axis that runs from north to south. And as you can see there, it's not vertical, it's tilted from the vertical. So there's your vertical, for example, there's your vertical line here, right? There's your tilt of roughly 23.5 degrees. We'll talk more about that as we're moving on. So there's your latitude, and we call them, these are lines, imaginary lines that runs from east to west. And the central line, the one in the center, as you saw here, is called the equator. Now, as you move on, let me erase all of these here. And as you move on, you'll find that you're going to have many more lines, right? We'll take all of these lines here off here, and we'll do that there. Right, so let's keep moving on to see you more lines of latitude. Okay, right. This is a very simplified diagram. We'll speak about this in a few moments as well. And there's your line of latitude. There's it here, the one that goes from there end to end, and that will be our line of latitude. Okay, let's just show you there. Right, we'll move these things there, and there's one line of latitude. There's it there. 29 degrees south line. The south means it's in the southern hemisphere. The next line is the one drawn all the way here. Sorry, not that one there. We just clear that one there off. We don't need the one there. The next line that we're now speaking about is a line that's moving all the way down here. And there's a line all the way here, which is 30 degrees south. So again, 29 degrees south and 30 degrees south. So between these two lines, you have a difference of 1 degree, right? Between those two lines, you have a difference of 1 degree. And that 1 degree is equated to 60 minutes. Therefore, you'll find what this question does, it has divided this entire block. The block has been divided into 10 minutes. There's it here, the 10 minutes. The next one, they've divided to 20 minutes. Halfway in the block is 30 minutes. And 40 minutes, it carries on there, and you'll find 50 minutes as you're moving down the line here, and there's a 30-minute line. The lines that are vertical, they're coming down. They're the lines here. Let's take a different color for that. And these lines coming down, the vertical lines are the lines of longitude. And there's it there, 20 degrees east. What that means that this area is in the Eastern Hemisphere. So two things about that, Southern Hemisphere and along the eastern side. So we know we're speaking about an area which is roughly in some parts of South Africa. Okay, and as you move further on, let's check the diagram quickly here, and you'll find that down here, and you'll find there's a map here again, showing your lines of longitude and lines of latitude. There's your line that's running that way, and those lines are lines of longitude and lines of latitude. Just try and get that off very quickly here. Let me clear all these things. Right, clear all drawings, right. So again, there's a map showing us lines of longitude and latitude. There's a line here. That line is a line of latitude, 29 degrees south. The next one here is 30 degrees south latitude. There's a line here of longitude coming down, and this here is 32 degrees longitude. There's 31 degrees longitude. So there's the area of Durban now. There's Durban. So if you ask the question, what is the location or the grid reference of Durban? If you ask the question, what will be the location or the grid reference of Durban? I'll give you a moment to be able to work the answer in your mind. I'm sure you're thinking about the answer, the grid reference of Durban. There's Durban. And we're asking, what is the grid reference of Durban? I'm sure you're done with that, and your answer should read as follows. You always give the latitude first, and therefore you'll say 29 degrees south. There's it there. You can't stop there because Durban is more than that. So it's 29 degrees south and 50 minutes. So it'll be 29 degrees and 50 minutes south. That should earn you 2 marks. 29 degrees and 50 minutes. There's Durban, and we have constructed our own line of latitude, and there it's there, 29 degrees and 50 minutes south. That scores you 2 marks, semicolon. Now we're going for its longitude, and there's our longitude here. It says 31 degrees east, and Durban lies right on that line. The line comes down there, and Durban lies right on that line. So Durban's longitude is going to be 31 degrees 00 minutes east. Okay, now what is the purpose of grid reference? Its purpose is to allow us to be able to find the location of places. Okay, and we'll see a question just now. Let's go back to our question here again. We spoke about this, the vertical lines drawn north to south. And those lines are referred to as the lines of longitude. Now, again, we need to know that the lines of longitude, and there's a map here, because these lines are required to be used. Okay, so question number 1.3, we said vertical lines drawn north to south, and those lines are the lines of longitude. And I was going to show you that those lines are important for us to be able to know. And there are our lines here, these lines coming all the way down here, and they're important for the calculation of time. There's the lines coming here. And the most important line for us in this case here is the Greenwich meridian. And like we said, it divides the Earth into an eastern hemisphere and then to the western hemisphere. All the way up here is the international date line. There's it all the way here at 190 degrees east of the Greenwich meridian. We'll come back to that in a few moments, in a few minutes' time, when we're doing time calculation. 1.4 equal length of day and night. So around about this time, which is September and March, September for the Southern Hemisphere and 21st of March in the Northern Hemisphere, it's called equinox. Equal length, equal length of day and night. And to help us understand that concept, I think we can quickly focus on a diagram here. And there's a diagram here. This will be 21st of March. The D diagram, it's the sun is striking directly at the equator, right? So there's the equator and the sun is striking directly at the equator, and there's the equator here, where you have an equal length of day and night. Then you have your 23rd of September, the one down here, and the sun is striking directly at the equator as well. So during these two positions, D and C, those are going to be the equinox time, where sun is striking directly at the equator. And therefore we said an equal length of day and night. Other times it'll be unequal, and we'll see it again just now. When there's unequal length of day and night, it's called solstice. It can be summer solstice, or it can be a winter solstice. And we'll talk more about that as we are moving on. Let's go on to question number 2, I think it is. Let's see where we are. We'll come back to our diagrams. Question number 2. Refer to the grid below and answer the questions that follow. What is found, which feature, which letter is found at the following coordinates? Now, 20 degrees and 10 minutes south. So let's go to find that line, right? 20 degrees and 10 minutes, 10-minute line, right? So let's go and see if we can find that line. 20 degrees and 10-minute line. Let's see where we are. Sorry, close this off here quickly. Right, 20 degrees and 10-minute line. Right, 20 degrees is there. There's it there. 20 degrees south line. There's it all the way there. It's a line of latitude. And 10 minutes more now. So there's it here. 10 minutes. And there's our line here. 20 degrees and 10 minutes south line. So somewhere on this line, you'll find your answer. Now, clever as we are, we don't even have to go and work out the longitude, which is 10 degrees and 50 minutes east, because on that line, there's only one answer, only one letter, which means that question number 2.1a, the answer is going to be A. Feature or letter A. But let's go and check. 10 degrees south and 50 minutes east, 10 degrees, it's east now. So it's 10 degrees longitude, there's it here. 10 degrees longitude, there's our line here, but it's more than 10 degrees. We're now going to 10 degrees and 50 minutes. So there's a line here. And on that line, where the two lines intersect, the one that we've drawn that way, the one that we've drawn that way, and where they intersect, there's our feature, letter A. Question B, 20 degrees and 10 and 30 minutes south. 20 degrees, there's our 20 degrees. Again, south, it's a line of latitude. There's our 20 degrees, but it's more than that. It's more than that. It's 30 minutes. So Sir has been kind to us. The block is divided. There's 10 minutes, there's 20 minutes, there's 30 minutes. So somewhere on this line here lies our answer. Unlike in this question here, A was the only letter. Now we've got two letters. Let's now go and find the line of longitude. 10 degrees and 15 minutes east. There's 10 degrees. There's our 10-degree line. And it says 15 minutes east. Now there's 10. There's 10. There's 20 minutes. So somewhere between these two lines, halfway will be 15 minutes. And there's our 15-minute line. There's it coming all the way here. And again, where those two lines intersect, that's your answer. And your answer is going to be letter X. Right, let's keep moving on. I'm sure you're marking your work and you're doing well as we are progressing. Question 2.2 now speaks about state the coordinates of point C. So there's point C. There's point C. Right, point C is 30 minutes south. It's 30 minutes south. We're going to find its degree value, right? So we move up here and the degree value will take it right all the way from here, which means that point C is 20 degrees and 30 minutes south. So point C would be 20 degrees. Let's just put it here, 20 degrees and 30 minutes south. Semicolon, there's it there, right? Semicolon, that's not coming in, no problem. Right, now we want its longitude, the long value. There's it now. There's your 40-minute line. So it's 40 minutes. Remember, it's 40 minutes east. But we can see there, it's the east. It's found in the eastern hemisphere. Now we want to know what the degree value is. You can't take 11 degrees because you haven't gone all that way. So you're going to work this way and check. Now it starts from here. And there's the answer there, 10 degrees and 40 minutes east. So there's your answer there. That may carry you a mark for there, a mark for there, could be more marks in the examination. The last question, calculate the straight line distance between point A and X if the scale is 1:50,000. Now, straight line distance also speaks about, is also as the bird flies or as a crow flies. So I've drawn the line for you from X to A. You're now required to measure in centimeters the distance on this map, on the diagram between X and A. And if you measured correctly, you should have got 3 centimeters. The scale is 50,000 centimeters. It's a ratio scale. Now we can read out the scale and we can record it as half a kilometer. It's the same thing. It just means it's easier to calculate. It's easier to work 3 centimeters times half a kilometer as compared to saying 3 centimeters times 50,000 centimeters. So if I walk for 50,000 centimeters and you walk for half a kilometer, which one of us will cover a larger distance, if ever at all? And yes, you are right. Both of us will cover the same distance because 50,000 centimeters is the same as half a kilometer. So it's straight line distance equals to the map distance times the scale of the map, which is 3 centimeters times 0.5 or half a kilometer. And what is half of 3 centimeters? Is 1,5 kilometers. That's how far these two places, A and X, would be in the real world. Right? So let's go and check. Now there's your answers. Quickly go and check your answers. Make sure you are doing correction if your answers are incorrect, but I trust that our answers are correct because we had sufficient application in preparation for our test that is coming up tomorrow morning. Right, let's keep going on to question number 3. Question number 3 says, identify the lines A, B, C, D, and E. We're going to find the diagram. I think it's earlier on. We're looking at the equinox diagram. Now watch here. We're looking at equinox. There's our sun's rays. And you can check the sun is striking directly at the equator, right? The sun's rays is striking directly at the equator. So there's the equator here. There's the middle line. That's the equator. So E is going to be the equator. There's it, E. Sun's rays is direct at the equator, and that means that these diagrams are showing you an equinox movement or an equinox phase in terms of the movement of the Earth around the sun. The sun does not move. The sun is fixed. The Earth is revolving around the sun. And hence we call that revolution. So area E is the equator. That should earn you 1 mark. Let's go for A. Northern hemisphere, and you are right. A is the Arctic Circle. B is going to be the Tropic of Cancer. Yes, you're correct. The Tropic of Cancer. C is the Antarctic Circle. There's it there. The Antarctic Circle. And D is going to be the Tropic of Capricorn. And that should score you 5 marks in the exams. Let's go check a diagram higher up, and we can probably find these things here. And there's it here again. That's a line there. Remember, the Earth is tilted. And there's it there, the Arctic Circle you saw there. There's the Arctic Circle. There's a Tropic of Cancer. There's it there, the Tropic of Cancer. In the middle is our equator, the Tropic of Capricorn, Southern Hemisphere, and there's the Antarctic Circle. Now, these lines here are important, the Tropic of Capricorn and the Tropic of Cancer. They're important to ascertain whether it's winter solstice or summer solstice. But we'll come back to the diagram in a few moments' time. Provide 2 reasons which help identify the above sketch as representing equinox. So we know that this diagram is going to be, is showing us equinox. And there's your answers here. The sun strikes directly at the equator. That'll carry you a mark. The sun strikes directly, and you can see it here. And the second reason we'll accept is that the areas received equal length of day and night. Right? So there's our diagram. There's your axis there, and you can see that the areas, one compares this half here, which is essentially your day. So this half here gets day in this diagram because sun is striking directly. This half here will get day because sun is striking directly along those areas there. This area here is away from the sun, and that will have darkness. Likewise, this part here is not facing the sun. It's therefore going to experience darkness. The dates that are shown here are the dates for equinox, 21st of March and 23rd of September. Okay, there's it there, 21st of March and 23rd of September. Comment on the length of day and night on this day, on the length. It's equinox, equal length of day and night. And therefore I got here, it's equal, right? Day and night is going to be equal. We'll see just now in cases where they're going to be unequal. Question 4.1, time calculation. We're asked to work out the time in Italy, which has a longitudinal position of 15 degrees east of the Greenwich meridian. Now we're working on the time from South Africa. We are currently at South Africa and we are located at 30 degrees east. And the time here is 2 o'clock in the afternoon. So what have we done? We have drawn our line. Now you must draw these lines as a means to check your answer. If you don't have these lines drawn and no working, your answer alone is not going to score you any marks. What have we done? And you can see here, we have drawn the 30-degree line, 30-degree east line. There's a line here, 30-degree east line. Why we've drawn this line? The question is telling us that we're working from 30 degrees east. We now want to find the time for Italy, which is located at 15 degrees east. Now, if we move this way towards the western side, as you can see here, it's increasing by 15 degrees each time. So it's 30, 45, 60, 75, it'll continue like that. But as you're going towards the western side, you're moving towards the equator at some point. So therefore, I'm gone 15 degrees east of this line here. Remember, it's north, right? So I'm now gone 15 degrees east of this line here. And there's my 15-degree east line. The difference in time is 1 hour. Because for every 15 degrees, the difference in time is 1 hour. And there I said, and as you move towards the west, the time is earlier as compared to this area here. If the time here is 2 o'clock, therefore the time in Italy will be 1 o'clock because the time is 1 hour earlier. Therefore, I got there 1400 hours minus 1 hour, which gives you 1300 hours. That'll score you 2 marks in the exam. If the time, the next question B, if the time in our country, again, 30 degrees east, we're working from there. That becomes a baseline, so to speak. And the time here is 2 o'clock. What would be the time in India that is 75 degrees east of our own location? Right, so let's get to the question. There's it here, 30 degrees east line. We must draw that line. Why are we drawing this line? The question is telling you 30 degrees east line, and the time there is 2 o'clock, right? 30 degrees east, time here is 2 o'clock. And it says, what will the time be in India that is 75 degrees east? And I told you earlier that it's changing by 15 degrees each time. So 30 plus 15 gives you 45 degrees. 45 plus 15 gives you 60 degrees. 60 degrees plus 15 give you 75 degrees. 75 plus 15 will give you 90 degrees. It's not drawn here, but the question says India 75 degrees. Don't go and draw more lines than is needed. And each one is an hour. So I've shown that here. 1 hour, next hour, next hour. But as you're going towards the east, the time is later. I spoke about the east, and I told you when you're doing the east, look at this word here, E-A-S-T. And the east means you're adding. You're adding. Where's the you're adding? The time in South Africa is 1400 hours. What will the time be in India? And India's time at the same time, when ours is 2 o'clock, it's 3 hours later. So I've added 3 hours. 14, that's 15, that's 16, and that's 17. So it's 5 p.m. right? So let's make sure you have all the answers taken down. For a brief moment, leave that there. Check that your answers have been taken down correctly. We'll go to question 4.1. There's it there, 1 o'clock. And question B 4.1, it's 5 o'clock. Okay, but again, you have to draw these lines. Just one last comment. Look at the question. It says 30 degrees east. So that's my starting point. 30 degrees east, 30 degrees east. This line here is not required. I've just drawn the line to show you that I'm moving towards the eastern side. It has no impact on the calculation of time. So don't go and draw more lines. It can be confusing for some of us. India was 75 degrees east, 30 plus 15, 45. 45 plus 15, 60. 60 plus 15, 75. We stop here because we are working for 75 degrees east. 1 hour, 2 hours, 3 hours, and east means your time is later. So I'm adding 3 hours to it. I'm certain you have that. If you don't, just go home and practice. The final question, question 5, talks about solstice. Now, solstice, we understand that solstice is going to be unequal length of day and night. Now, here you can see there's your axis, right? The north-south line here, and the sun is striking on this half here. So this area gets direct sun's rays, and like you can see here, that area there is night because it's facing away from the sun. Now, solstice can be a winter solstice or it can be a summer solstice. Let's check where the sun is striking. So there's the equator. There's your equator. The equator is going to be right here. There's the equator here. There's your equator all the way here. There's the equator here. Where is the sun striking? There's the equator. Where is our sun striking? And yes, you are correct. It's striking in the northern hemisphere. So people in the northern hemisphere are experiencing summer. And we that live in the southern hemisphere are experiencing winter. In which month do we experience winter? Essentially the months of April, May, June. So this is a June diagram for us. So in June, it's winter for us, and it's the opposite for the people in the northern hemisphere. So they're having summer because the sun is striking directly on the Tropic of Cancer. Check this diagram here out. There's a diagram. There's our diagram. And you'll note, there's a there. You'll note our diagram. There's your equator. Question was asked earlier. There's the equator, and it's labeled for us. There's the equator. Where's our sun striking? There's it here. The sun is striking on this line here, which is the Tropic of Cancer. And that's your northern hemisphere now. There's our Tropic of Capricorn down here. Sun is not striking. And you can see that the earth is tilted, that the northern hemisphere is tilted towards the sun. So there's a northern hemisphere here. There's a northern hemisphere here. It's tilted towards the sun. Whereas the southern hemisphere is tilted away from the sun. The southern hemisphere is tilted away from the sun, right? There's our southern hemisphere here, and it's tilted, it's tilted away from the sun. There's a tilt in that direction there. So it's winter for us, and it's summer for the people in the northern hemisphere, right? So let's see quickly the diagram. If we go back up here, right, the diagram we have, what date does a sketch represent? Now the date here is going to be a date for us now. is going to be a date in June. So the 21st of June. Give 2 reasons for your answer. Why are we saying that it's 21st of June? Why are we saying it's a winter solstice? Isn't there? Which hemisphere experiences the winter solstice? We get the winter solstice, southern hemisphere. Why? The sun is striking the Tropic of Cancer, which is in the northern hemisphere. The southern hemisphere is tilted away from the sun. Right? Which hemisphere? We're back to question 5.2. We said, give 2 reasons for your answer. Why are you saying that it's the 21st of June? Firstly, the sun is striking directly on the Tropic of Cancer. The southern hemisphere is tilted away from the sun. The northern hemisphere is tilted towards the sun. There's a northern hemisphere here. It's tilted towards the sun. Question 5.3, which hemisphere experiences a winter solstice? It's going to be the southern hemisphere. Down there's the equator here, the southern hemisphere. We are experiencing winter. It's June for us and it's winter. I'm sure by now you realize that we are moving into winter. March, April, May, June. What happens to us during winter? The hours of darkness, the length of darkness is going to be longer. So at 5 in the morning, it's still dark. Therefore, we say that there'll be unequal lengths of day and night. Question number 5.4. Comment on the length of day and night in the northern hemisphere, right? Comment on the length of day and night in the northern hemisphere. Now, the sun is striking the northern hemisphere. That means days would be longer, right? The days would be longer and the nights or the hours of darkness would be shorter, right? Comment the length, the days would be longer and the hours of darkness is going to be shorter. Why? Because the sun is striking in the northern hemisphere. There'll be more hours of sunlight. And if you go back and you compare, and you check here, for example, take this one here, there's a line there, right? Compare that line there to this line here, to that line there. You compare the hours of darkness, right? This line here should be longer. Therefore, we're saying that you have longer days and the length of darkness is going to be shorter. So there's your length of darkness there. That's your length of darkness. And here is going to be your length of the day. There's it there. 5.5. On which other day does this phenomenon occur? Now it takes place on the 21st of June. That's your summer solstice for the northern hemisphere, winter solstice for us. It's the opposite seasons now. That's your seasonal variation. So it takes place on the 21st of June, and it's going to take place for us now on the 21st, 22nd of December. So it takes place on the 21st of June, and when the sun is striking the southern hemisphere, that's our summer solstice. The sun is striking the southern hemisphere, and that means we will now experience the summer solstice for us now, right? Let's get rid of this diagram and let's see where we are. Let's clear all of those things, fixed up, right? Let's close that there. So there's a diagram again, like I spoke to you earlier, and there's your memo now for that question. And I'm sure you've been marking as you're moving along. And there I said you here, 21st, 22nd of December. That's where the sun will strike for us, and we are going to be experiencing the longer hours of day. As you know, in December, we can be on the beach, we can be at the beach, and 6 and 7 o'clock, 7 p.m. in the evening, we still have some hours of brightness. And therefore, we're saying that we are going to be able to experience longer hours of day and shorter hours of darkness. All right, so learners, I'm sure you've marked your work and you are ready for the test that takes place tomorrow. Best of luck. Remember to carry your own page. Probably require a single page, ruler, pencil, calculator. Please draw a margin on the right-hand side of your page in which we'll record our marks, your surname, your name, the date, test number. Remember that this is a formal assessment. It's going to be part of your term mark for term 1. Any incomplete answers will be marked wrong. Working not shown is going to be marked wrong. Right? Should you have any challenges and you want to check, you can check with learners in your class. Your parents might be able to assist you, or if you want some direction from Mr. Mkabela who's at school, please do so. So thank you and best of luck to each of you.